the winter is coming, and we are not talking about the skiing this time, but we are talking about how we are coping with the energy over the winter. And we are having great panelists here, and I would like to introduce those all. So if you could start, please.
Good afternoon. My name is Harri, Hahkala. I'm working as a technology manager in Metropolia University of Technology, and my field is there mainly smart buildings, energy efficiency, and so on.
Yes, my name is Dennis Hauer, Architect Director at Urban Climate Architects, a Dutch architectural office in Delft. And we focus mainly on buildings in the existing city. So we also have a lot of existing buildings which are part of our portfolio. And there, of course, question about energy and how you deal with energy saving is quite important in those cases.
Yeah. And good afternoon. So my name is Jyrki Laurikainen, and I'm the CEO of RAKLI, the Finnish property owners. So our typical member is owning for the life cycle a pretty large portfolio of buildings or other infrastructure.
Hi, my name is Janne. I'm working at Platform Trust as a product manager. And later on in this session, I'm going to demo a short solution from us also, which is touching the subject. So happy to be here.
Thank you very much. And my name is Antti Harjunpää. I'm CEO of Platform Trust. And I do have a bit of a background in energy, actually creating it in nuclear power plants, and nowadays looking at it from the construction and from the property viewpoints. And like we saw, we have a good combination. We have a planning side here, and we do have the property owner side as well. And we are going to start from a little bit of the strategic level. So the first question, what type of ecosystems you are involved in related to the built environment?
Yeah, of course, we have now in Eastern Helsinki new campus, 60,000 square meter, and there all the building is learning space and living lab. So we didn't just build up walls and classrooms, but every corridor and heat distribution room and whatever, they are educational spaces, and we utilize them all the time. And yeah, that's one ecosystem, because we invite companies there, and we have this, for example, smart lab, which is one candidate in this world, Gala and so on. So build up, let's say, block house apartment inside one lab and have all kind of sensors and building services there and so on. So, but of course, we have been together with Platform Trust almost day one and so on to develop that also. And of course, Kira Hub is one ecosystem where we have been quite some time.
Cool. And now I would like to ask, because the Netherlands is kind of really international place, kind of middle of almost every European country. Mm-hmm. So what kind of ecosystems you are involved?
Yeah, what do you specifically mean with ecosystems? Can you explain that a bit?
Yeah, when I talk about the ecosystems, I mean that the group of organizations or companies kind of scattered around to solve one or two problems together.
Yeah, okay. Yeah, I think we are mostly involved in a group of companies who are basically working on more the problems, how to work with bio-based and circular solutions. Yes. And from that, of course, the energy component is one part of that. And you see that's a very wide range of companies. There are municipalities involved, but of course also architects, product deliverers. So you see that's a quite wide network with people who are trying to come up with smarter solutions for on a circular level.
Okay, cool. What about
from my perspective, not deep diving into that, what is the difference between network and ecosystem, but it's basically my job as a head of a association of the building owners. So there's multiple different ecosystems. I mean, whether it's related to the Green Building Council or whether it's related to integrated project delivery or the Lean Construction Institute. What I want to probably highlight there is more or less the ecosystem of those companies, organizations who have committed to the energy efficiency program. And there's roughly 150 organizations in Finland who more or less is doing on the portfolio level a good work for the energy efficiency. And we have, I mean, couple of events for them. Then at that time, I'm more or less, I mean, spreading the best practices on that side. So can highlight that one.
Yeah, cool. What about you, Jan?
Well, I think from platform trust point of view, I think we work with multiple ecosystems. You know, every company wants to be the center of their own ecosystem, of course, and we are kind of like a player who is combining ecosystems and acting as the middleman to create trust there. So I think that's kind of our natural role as a company.
Yeah, cool. Yeah, generally about this ecosystem term, it's interesting because the perspective and way of doing business is kind of a bit different than we have used to. Because normally there's just a customer and then there is somebody who's selling services for them, and ecosystem, there are multiple companies around there. So it's actually a little bit complex and a new way of working. Yeah. But I think it's quite interesting.
Yeah, I think the word ecosystem also implies that you need to find a group of companies and people which bring a certain balance to each other and can help each other to make it stronger and really get a system going.
Yes, it's true, and there's actually quite recent research that roughly 17% of the ecosystems actually succeed, and that there are multiple stages where actually it can go wrong, but still it can be successful. All right, so. And then the strategic importance of energy savings in your organizations.
Yeah, but I think what we see, of course, we design buildings, so we always as architects we think we can save the world and make it a better place. But in the end, of course, our impact is quite small because. Yes. I think in the Netherlands we have an existing building stock of around, I believe, 6.8 million homes. We are in need of, they say, around 1 million new homes over the upcoming years. But basically, we are just doing a small part of that. And by doing a small part of that, you also know that there is a big part of an existing situation which you simply can't reach. But the interesting is, and what you see now in the Netherlands is that basically you see that behavior is a very strong aspect. So the way people behave and see for themselves that they can have influence on the way they use energy. And the interesting thing is to find an incentive with that. Well, at this moment, it's quite a hard lesson, of course, with the prices going up. But you actually see it works because you see that when people started thinking about it, in the Netherlands, the energy savings this year was 25% higher than last year until now. And that's, and of course, in some cases, it's a very sad story because there are also people who actually even can't pay almost, so they put out the heating because they simply can't afford it. So that's maybe it's not a good incentive, but you can see that behavior has a very strong role on the use of energy.
Actually, the one bit of a side questions which I always wanted to ask, because especially from the architects, because when you design a building, it's long lasting. I mean, it can take like 100 years. Yeah. And but how do you kind of follow or how do you know that the buildings are actually used in the way as you designed those, or is there a way?
Well, I think if you look to the more circular approach, there a system we use a lot is a system where you where you break up your building in layers. It's a system by Stuart Brand, and the idea is to have a look at each component and see how much time it lasts. So, for instance, if you make a construction of a building, you design it to last for 200 or maybe even longer, 200 years, maybe even longer. But if you look at the facade, you know that in about 30 or 40 years, it's probably in need of a restoration, or it's so old, or there are new techniques which you maybe can you have better ways to insulate it. So you also have to design it for that. And that's also part of the circular economy, that when you are going to renovate the building, that you can take out the material and use it for something else. And when you go to the inside, that even is a step further, because for instance, if you talk about inside walls, well, you can design them for maybe a period of 5 or 10 years, and it also helps you to be able to be more flexible with your building. What we do a lot also in housing projects is design a flexible building casco, and where the inside can change, so that if you want to change it, that it's also changeable to the future. And especially also in houses, in apartment buildings, for instance, that's quite common, because what you see more and more is that people stay longer in their house and simply want a house which can grow or become smaller with them, depending on what phase they are in their life.
Yeah. Oh, it's really fascinating. Cool. So what about you, Harri? What do you think about this strategic energy savings in your properties?
Of course, our responsibility in education is that we have to make sure that all the students who finish the school can have updated knowledge, and they can bring, let's say, change in the new working places and so on. And of course, we have lots of different kind of research project, and we try to help our owners, which are Helsinki city and other surrounding cities there, so to make help them also make energy efficient things. And but in Metropolia, of course, itself, we try to reduce energy usage and so on, and make our own facilities very efficient.
So has there been any research on how the conditions actually affect the studying results?
Not exactly. There has been some research early years that how the temperature rise will, for example, affect the speed of typing or something like that. That's kind of course, there has been studies, but that's, let's say, one of those.
Okay, so let's go to KPIs, the numbers a little bit, and then I would like to point to Jyrki, because I know you have a long history in properties, and what kind of KPIs we should and could and maybe already have in the area, especially in a portfolio level.
Yeah, I mean, I don't remember exactly the KPI numbers. I can talk about the KPIs and and about the strategic importance. So I mean, from RAKLI, our members' point of view, I mean, since they own big portfolios of buildings, so the whole energy topic has been a key strategic topic for roughly 10 years.
Yes.
And it's born more or less on the, of course, I mean, what are the quickies that you can do, but then also what do you do when you invest? So it's a bit of longer the perspective on that side. Now, a couple of years ago, it changed so that the CO2 and the climate change was more or less the key thing, and then we more or less added about the own production, and if that's not enough, and then you buy, the green energy. And now, because of the reasons you all know, the focus is again, how do you, save energy tomorrow?
Yeah, true.
And then what you look, if what I've referred already to the energy efficiency commitment program, if I translate it that way, there's a percentage targets that how much you need to in your total portfolio to achieve energy savings. So that's pretty easy one. It's really a kilowatts then out of your whole portfolio, and that's of course an important one. And second one, of course, is then the CO2s. So majority of our members are already committed or thinking to committed also to neutrality on the CO2 side. And of course, really minimize what you need then, what's left there after that. For the energy usage sides, it's pretty far there. like really key thing. But that 2 KPIs, CO2s and kilowatts per something, then it depends where you.
So CO2 and kilowatts.
Yeah, and of money, of course.
Yeah. All right, Janne, you had it.
Yeah, I think what Jyrki said is correct, and I think from I have an example from a household customer. I just bought a new home a couple of years ago, and it's kind of for me at least, it's kind of future-proofing your investment if you think about energy saving and so on. So it's kind of I'm not back then 2 years ago I didn't think about electricity prices or so because it was so cheap, to be honest. And that might be ending now as we learned, but it's still like future proofing it's a hell of a lot of investment as a household customer which home you buy. So if you get this green certificate or whatever, then of course you could get green loans from your bank, and the business case is kind of holistic in my view.
That's really important. It's the value of the building. And I mean, if you look now back these years, I mean, it used to be that if you had a LEED certificate, I mean, you could be somehow special. And in certain areas, it's already the situation that if you don't have any certificate, you are more or less out. I mean, the lessee is not interested in because you are not, I mean, at the level that we want that you are.
Then the question actually back to planning, because if you save too much, isn't it so that then the building is not used any longer as planned, and then it actually might be ruined? So is there any KPIs from that viewpoint? No, this is from the planning, for the architect.
Yeah.
Because thinking it from that if we save too much energy, and then the conditions, humidity, maybe temperature might go too low.
Mm-hmm.
So is there any KPIs which could be followed to stop that progress so that we don't put the heat too low in the buildings, or is it a threat at all?
I don't know if it's a threat. I think it's more or less about how comfortable. It's more a comfort question, of course.
Yeah.
And it's finding a right balance in that. And what you see when you have really good isolated homes with really good passive solutions, as we design new homes nowadays, then you see that you almost don't lose any heat out of the house, and there is even started to arise a problem in the summer because the houses actually are too warm then.
All right.
So actually what we see now is that over the years with also better isolating our houses, that even the summer is becoming more a problem than the winter, because if the heat is in the house, it doesn't get out anymore. So I think that's the other side of the medal.
That's actually what's happening at my apartment.
Yeah.
At least during last summer. So that's exactly what you said.
We did a project in the city of Groningen, which was a big housing project also with 4-sided orientation, so freestanding building, and we made some temperature predictions based on a simulation. And we had actually a situation on January 13th where on the west side of the building in the morning, the heating had to be on, and on the east side, we had to cool it because it became too warm in the sun.
So what about you, Harri? I mean, any ideas about even producing some energy?
Yeah, of course, this solar panels and so on, they have been quite, let's say, popular nowadays because of the price and so on. And of course, I have this reminder in my pocket. We were talking about this today. So this is €5, which I charged my energy company on July from electricity. So I sold more than I used. So, and in August it was €15 I got back. So, but okay, it's changing now when the fixed price is gone. But
not much. But if you multiply it with 1 million or 10 million, then it's
Can you save too much on energy side? I think that the indoor air quality is the thing. I mean, you promise something to your lessee for the actual user of this space, and there are studies that shows that, I mean, if you worsen more or less the indoor air quality too much, the productivity really drops, especially it comes through when it's too hot. That's probably the easiest one over there. So something to be measured is the indoor air quality. And okay, now if you put the ventilation totally down, it's totally, I mean, not the right thing to do. You can do it temporarily. If you do it for 2 hours, it's no difference. Nobody, I mean, notice except in meeting rooms.
Yeah.
But indoor air quality, I would say that it's something to be followed.
Yeah, and just thinking on that, I'm also thinking if you're talking about will it harm your building, for instance, if you take it down too low.
Yeah.
I think it might would, because in the winter when you have maybe higher humidity and it becomes too cold, also will get more moisture in the house.
Yeah.
And you will have the risk of also getting moisture or that so that it will affect also the quality of the real estate itself.
Okay. And then another question actually about, we talked about this small streams, saving or actually even producing. Do you think it's enough to have the small streams to save and produce energy? Will it save us?
I think it's part of the solution, because I think the main problem with energy is, of course, that you have to find a way to get what you use to get that to the same amount of what you produce. And the problem is that it's really going up and down. So there are parts of the day when you hardly use any energy, and there are parts of the day which you use a lot. But you have to find a way to get some kind of constant production, or else it's almost impossible to come to that demand. And I think that's also the first thing. I think if you look at houses in the Netherlands, we have, I don't know how that's over here, but we have two different kinds of pricing for electricity. So during the day, it's more expensive than during the night. So that means what you see a lot of times is that people are putting on their washing machine, the dishwasher, they're doing it all at night. But what you see now is when, for instance, when you're buying solar panels and you put them on your house, then it's better not to do that, because then it's better to use the energy when you're producing it, because in the end it's better to use it than that because that will save you more than that you will give it back to the energy company.
Okay. What about checking some practical examples between?
Why not? So kind of a good leeway, as you said, about the indoor air quality and about the electricity stock prices, which are of course lower in the night than in the daytime. So we had this a case by us as Platform of Trust, this smart energy company called Eneman, and Metropolia was part of this, and then we had an AI partner in Germany called Unetic, part of this. So this was an ecosystem play to kind of solve this dilemma that how could we save energy, how could we save CO2 emissions and create ultimately cost savings to the customer. I think we touched here is a kind of a high-level architectural overview on the solution, what we're doing, and I wonder if the laser pointer is working. Cool. So Platform of Trust is here, and here is the building which we are reading data and controlling the ventilation and the heating. So that's exactly what Harri just explained, but we use other data sources as well here on the right. So we use the stock market energy cost, and then we use weather data also. So we know what the weather is going to be like in a couple of days, so we can do predictive AI controlling of the heating, for example. So and then we feed all this into this AI engine here, and then we control the building's heating and ventilation through that model. And what we did is we trained the AI engine with over 1 year of data from the building and how it performs, and that was used to teach the AI engine. And what was the objective? Why did we do this? We wanted to target 15% of energy consumption reduction and generate potentially 1,600 euros of cost savings per year, and 15% emissions reductions. And maybe the last part is most important. We didn't want to sacrifice user comfort or satisfaction at all. So the temperatures, indoor air quality, they shouldn't be compromised at all. So that was the key part. So of course, like we discussed, if you turn on the ventilation completely, you will save money, but of course people are miserable in the building. So it doesn't really work. It doesn't work as a business case. So what I wanted to show on the dashboard is that when the energy prices are low and the amount of renewable energy in the market is high, then we want to push the heating of the building to kind of heat it in a bit of advance if we know that for example, it's going to be cold in a couple of days. So we want to push the heat then when there's a lot of renewable energy in the market and when the prices are low. So that's kind of the idea of this solution. And yeah, that's basically it. Oh, and then the 100% satisfaction of the building users. We have like a lower and upper limit of CO2 levels also. So when it's about to drop or go too high on the threshold values, then we increase the control of the heating and ventilation as such.
So basically there was a question for the online listeners about that if an energy kind of a bank can be used to store the energy during the nighttime or during the cheap times of energy.
Yeah, that's a really good comment, and that's actually, like you said, it's actually what some households are already doing with their electrical car, because it's basically a huge battery which you can recharge in the night, and then during the day you can use it for consuming data or electricity. We haven't implemented that yet in this solution, but it's a good next step to consider, most definitely. Yes.
And I kind of think, because I think Harri just mentioned yesterday that actually even the building actually stores the energy.
Yeah, or in this case, when you know the weather forecast or energy price forecast or energy emission forecast or whatever.
Yes.
So you can make beforehand, let's say, cooling inside the building, so that because it's hot tomorrow, so you can make a power peaks cut. So you don't need very much power then when the sensor says that it's hot.
Exactly. Yes.
So you make it, yeah.
Yes. And there's some kind of fancy term for that. It's something like heating lag or something. So you can push heating into a building, and if it's cold the next day, for example, it still stays, like you said, in the Netherlands, when it's insulated, the buildings, the heating stays inside, even though it goes cold, tomorrow, for example. So.
And if you have solar energy, so you can either store it or so, because it's cheap today, but to sell tomorrow if it's expensive.
Exactly.
Or something.
Yeah.
And in this picture, you say you use sensor data in the building. What aspects are you using the sensors for? So what are you measuring?
We're measuring, I think, 5 or 6 different measures. So like temperature, CO2, I think current heating, consumption, or what's the kind of the drive value. Maybe Harri actually knows better, but I think it's like HVAC, systems, and basically we pull everything we get there and then analyze which we could, train the AI smarter. So.
In the beginning of this project, we teach this AI agent with our campus data, so tested how learnable it is and so on, and then we could, let's say, offer for Stavanger and Helsinki city that engine or solution.
Yeah.
So how about, can I ask a question?
Of course.
Yeah.
Yes.
So how about looking at this from the portfolio level?
I can answer from portfolio level. I mean, this type of smart, let's say, energy usage systems are really critical especially now when we more or less have the problem that do we have enough electricity on the national level. Yeah. So everything that we can move to be in those non-peak hours, so basically from 8 to 11 in the morning and 5 to 9 in the evening are the times that you should limit your energy usage. Exactly. So if you are, and we are, as you can see, we are able to do, for example, heat the hot water or whatever during those those times. It's of course you say save the money if you are not on the stock price, but it's also from the whole point of view, you should more or less carry what you can to the big bucket of all of ours, so that we have enough energy in Finland, in every other country. And also let's say the big and easy ones are done when we look at from the big portfolios. They most likely have done the low-hanging fruits. So we do need these. And also kind of the answer to the previous question that yes, the small streams are also important because the easy ones are already done. Yeah. But I would say that at this moment, I mean, this type of smart solutions are really valuable.
And if I can comment still, I mean, this is like, in my opinion, like a perfect AI optimization case, because you have, strict rules which you can, teach to the algorithm, and then you have these quite nice data sources to connect it to. And for example, as a property owner, you might want to, emphasize more on the, the CO2 reductions, for example, or you want to just, or more put the emphasis on the electricity price, for example. You can do different kind of, multipliers on this, because usually the energy or the energy price is low when the amount of renewables in the market is high. But as we can see from the data, not always. So there are cases where these overlap a bit. So you can use these inputs to kind of optimize just your portfolio or your building.
If you look to the building skin of a building, is the system suitable for every building, depending on what the quality of the facade is? So, for instance, is it if you have a really bad isolated building, do you get the same effect then, or would the first step always be try to do something to the skin of the building?
Well, maybe Harri can take this. This is more like on the big
I think
side.
it's you don't have to have a nearly zero energy building or something like that, because it's more than you should have certain automation system which can control, and you get data, and you have some sensors there. But that's I think
you need to do both.
Yeah.
Yes. And like Jyrki said, it's kind of the low-hanging fruit. Of course, is put the emphasis on the shell of the building. But of course, if you have these capabilities of reading data and controlling the systems outside, then of course this is suitable. No matter what about the installation.
Yeah. So can you tell something about the challenges in actual data exchange in there?
Yeah, sure. We did this for a city in Finland, and to pull this off, to make this into production, our city customer municipalities, they said that they probably needed to break like 10 internal policies to make this happen. Because if you think about it, we are exchanging data, building data through interfaces outside the organization to a German partner in the other side of the ecosystem, and then back, controlling the building. And of course, the questions were like, first questions were that what if the Chinese can control our building? We don't want that. So please make our lives easier and explain how are you doing this? So we don't want Chinese people to hijack our system.
Yeah. All right. Thank you very much.
Thank you.
Okay, so let's go back for the because I don't think there must be, and I know there are multiple cases which you might be already doing. So what kind of case examples you have, but are not this one, but similar, which are done already for the energy savings?
I think I have a project, but it's already quite some times ago, which is also a school building actually, where we also worked with quite a similar system. Yeah. I think there was a total, but the system was even also taken it a step further. It was also combined with the whole building communication system. And you could also put other nice elements to it. For instance, it was also self-learning, so it would recognize patterns to see which spaces are used a lot and which not. And the interesting thing for that is that you could also combine it, for instance, with the cleaning protocol. So if you knew that the classroom wasn't used for a few days, you didn't have to clean it. But also from a safety aspect, for instance, that he also measured the temperature of light bulbs, and when the temperature got up, then he would shut it down for itself. And turn it up again after a minute. And if it would heat up again, then he would give a signal to the building manager, hey, there's something wrong with your light. So it was actually a quite smart system, which is also not only for energy saving, but also wider. And the interesting thing with that project was that it was the first project which this party did in the Netherlands.
Yeah.
And we had a client who was first a bit skeptical about it also, because he really wants, I want to try it, but what if it doesn't do what it was supposed to do? Then So in the end he chose to have the all ventilation and heating system, which was air guided, to be at least layout for 100% usage. And in the end, they monitored the system, and they saw that after 1 year, the system was never running more than 16%, even when it was even during the opening, when there were 2,000 people in the building. So,
all right.
So that's, but that was also a system that's also why I was asking the question about the sensors. But there were actually quite a lot of sensors. He was also measuring the temperature heat of the walls, the heat of the floors, the heat of the ceilings, everything to predict how much energy he had to put into the classroom to get it warm or cool.
Yeah, sounds fascinating. What about you, Jyrki? What kind of examples you might have?
I mean, of course, there's multiple different softwares which are doing, let's say, probably not exactly similar, but also those. One example that I remember is about the company and their software, which is doing for the typical apartment buildings, that during the morning times, for example, when people taking showers, and then in the evenings, early 5 o'clock when they cook. So in every case, there will be heat load from these actions. So basically you can simply lower the centralized heating system at those times. Otherwise the temperature in the buildings will raise. And I mean the people would not notice anything, and you get so that's an example of one software. What I like about this type of thing, when we look at it from the bigger portfolio point of view, that there are different systems in different buildings, and then you still connect some external data into it. And from the last portfolio owner point of view, you should be able to do it in every building. So the system should have the capability that you can connect different building management systems into it, and then the external data into it. And then I had the question that how was kind of the usage of the space? Is that data part of this practice? So is there somebody in a room, or what's the level?
I think it's the CO2
sensors.
Yes, exactly.
Okay.
So that you can derive that.
All right. What about you, Harri? Do you have knowledge of?
Yeah, there is a smaller project going on, like a little bit similar, but let's say more simpler. So that there is like a Raspberry Pi and some relays, and you can easily program some sentences that when your car is going to load is loaded with electricity, or when your heat tank is going on, or whatever. So it's very simple way to put, and mostly to small houses. But of course, in this case, a little bit similar than you were explaining in our campus. So we have connected all our automation data through Platforms Trust, and then we utilize it as in our building information system, empathic building, and then there is also space management system in our TM who utilizes it, because it's very convenient that we have this data stream straight from automation system to Platforms Trust, and then we can share our data, different sources and interfaces. So we don't have to build up all the unique data stream again and again. So,
Any questions from audience?
Regarding this Helsinki-Stavanger case that is described here and the end user perspective, the resident perspective, did he or she have an access to the insights of the data, and then what kind of insights did he have?
Well, good question. I think in these cases there was just for example, there was a notification first that we are running this, smart energy saving, pilot, and if you have any feedback or you notice something, please, reach out to us and send feedback. But I think the residents, I think if I'm not mistaken, it's like a elementary school or a school for first graders and so on, and the Stavanger case was a kindergarten. So kind of, I mean, maybe the kind of end users, the kids didn't have any access to the data, but of course that's a nice suggestion also, that they could use the data in their own studies to if they would like to study the field or do a project on it. So why not? Yeah.
There was another question. Somebody raised their hand. Cool, thanks.
Use of, can you hear?
Yes.
Use of external power or even power generator can be used to the buildings which have, for example, this kind of backup needs. And normally it's in service level. There is a couple of days from the month that it must be tested, the system and things like that. The backup generators, we are looking that way, that when it's very high level, the use of electricity, we are trying to look at and optimize that use of backup generators exactly for that timing. But same can be used same way with whatever external asset what you have available in your system.
Yes.
Yep. Good comment.
Good comment. All right. Anything else? All right. So we are gonna go for the kind of final stage, and just one comment. Actually, two questions are still there. We know, of course, because we are actually in this meeting, there are a lot of digital people in here and who like digital. We like PropTech as well, and the properties, but we are mainly digital. And if we are looking at it from the, let's say, more like a property people viewpoint, is there maybe something easier or faster than this kind of approach to start the kind of energy savings?
But I think what makes this different is that it has the AI component in it, so that it's self-regulating and also can use data. What you see most of the time is that there are simpler tools used, for instance, in houses, that everybody has a display on which you show the use of energy and that you at least have it visible for yourself, and that really helps you already by getting a kind of sense of it. Okay, hey, something is using energy, but I don't have a machine on. What is it? And I think there's a really small connection also to small additions by, for instance, regulating sun protection, or so we see that there are some smaller systems, but they're not so smart. They're more based on an action or a handling.
Human based.
Yeah.
Okay. Yeah. Okay. Then the final question, and it's going to be a full round, so pre-prepared. And the winter is coming, and the gas pipe is broken at the moment. So what do you think? Are we going to survive, and how we are going to survive the next winter with the energy what we have? Starting from you, Jan.
Well, that's a tough question, and I think it's a burning question now for the past week, if you've been watching the news about the gas pipe. But I think at least the West against the Russian gas, I think the West has been quite unified. I think at least I was positively surprised on the reaction of the Russian gas. So it seems like Germany and other countries in the middle Europe, and maybe you can talk about Netherlands too. But I think we're surviving quite well. People realize that the electricity won't be, close to free anymore. So we will have to pay a price for it. But I think inflation is now going on, and all the prices are going up. So I think it's a larger issue as well. But kind of long story short, we will survive the winter. I'm positive out of it.
Yeah, it's predicting to the future is interesting, but a bit of the numbers. I mean, it's 15,000 megawatts. I'm not looking from the Finnish point of view, and I'm from Fingrid's point of view. So we talk about the 15,000 megawatts, which is the all-time high. And then you take more or less the risk. I mean, there's no more electricity from the Russian. Basically, the Olkiluoto 3 can handle that one, so there's more or less the first risk. And then you more or less come to the water resources, especially in Sweden and Norway. So we do get kind of the electricity that we get from Sweden is an important one. And then the solution that, okay, the worst case is something like missing of 2,200, something like that. If we end up to the situation that Finland start to cut down the electricity, it will be like 200 megas each. Yeah. And then I take an example of one big building owner is basically out of their portfolio temporarily for a couple of hours able to do 20 megas. So there are ways that even though that we would come closer to the worst situations, there are still something that we could do already on the real estate side. Yeah. On the other hand, when you come to the evening periods where the households are really, really important, we need all of us. So my answer is still that I do believe that we do survive and of course hope that we will not have any energy cuts, but we do need everybody over there. So you need to, I mean, so everybody on board. Yeah. So it's important to everybody. If all of us put the saunas, the electrical ones, on at the same time when there is no wind and it's minus 25, we might be in trouble. But since, I mean, we are clever people in Finland, we will survive.
All right.
Yeah, I think the Netherlands is a completely different situation than over here. At one side, of course, we have a more milder climate, so we're not used of having really cold winters. And I think if you look to the part of energy saving, where the aim was about 20%, you see that we're already below that. So from that point of view, I think we're in the good direction. On the other side is the energy demand in the Netherlands is for a big part gas based. The gas storages are already full, so basically we have enough gas to survive a normal winter. And I think from the energy part, over the last years, also the production of energy was more and more also on the renewables. So I think about 30% of our total electricity usage is done by wind from the sea. And unfortunately, I have to say, they decided to, because a big part of the electricity demand is also done by gas-powered centrals. They want to close them down, of course. And unfortunately, they are opening up some coal centrals again. So which will at least provide us with enough electricity, but will throw us back quite some years in the goals to get to the CO2 reduction, unfortunately. So then over there you also see that, well, the economy wins over ecology in this case.
So will the renewable part kind of speed up again in future years?
Yeah, I think so, because what you saw, we had especially mainly, of course, we have some wind parks in the sea, which are not that old and also still expanding. But what we see also is that there we already had quite some windmills on the land. You see that it was an old generation. They were about 15, 20 years old, and they're replacing them now. And what you see is that the ones they're replacing them with provide for almost 10 times as much electricity as the old ones. So I think they're working a lot on getting that part higher over the next years. So it will take some years, but I think in a few years, well, of course, we have a lot of wind. So why don't we use it?
All right, thanks. Okay, then the final answer, the correct answer.
I think there is this silver ring in this cloud also, because now if we think about many people didn't know how much they use electricity or something like that half a year ago. And now everyone knows how much energy, how high is the bill and so on. And I think now these new solutions will come and we can reach also those high hanging fruits, and it's profitable for building owners and so on. So
Agreed.
I think hopefully this will last only this winter, but anyway.
And let's hope Germany keeps their nuclear plants open.
Yes. All right. So let's go, everybody, to grab some high-hanging fruits over the next winter. Thank you very much for listening. And thanks for the panelists. It's really, really nice and great to have you here.
Thank you.
Thank you.